Hello, it's Duncan. I'm taking a break from Gilded Rose today for another mini-series. A long time ago, a very clever chap called Keith Braithwaite ran workshops titled TDD as if you meant it. He made the participants stick to the rules of TDD. Write production code only to pass a failing unit test. Write no more of a unit test than sufficient to fail. Write no more production code than necessary to pass the one failing unit test. And refactor only on green. This is actually quite hard, but the resulting code is often very simple and unencumbered by our previous experience. Very simple and unencumbered are not adjectives that can usually be applied to JSON parsers, especially on the JVM. I've always wanted a parser that I could copy into a project in one file, so I thought that now would be a good time to write one. And as an experiment, instead of reading up on lexers and tokenisation, I'm going to write tests and keep on doing the simplest thing that could possibly work. Here we are with a brand new project as set up by IntelliJ, and I made two changes so far. The first is that I have added strict as an assertions library, because I rather like it. And the second is that in source test, I've added an examples file of things I think we should worry about. So we look at the top, these are all strings which I think are valid JSON. So null is a valid JSON string. True and false are valid JSON strings. By the way, so are these things with white space around them. We'll need to worry about that at some point. There are different formats of numbers. There are different strings, including strings with embedded quotes and other escapes. There are different forms of empty objects with white space inside them, with a line break inside, and so on. And I've added a single level object with examples of the primitives, with different amounts of white space around things, and then a version of that taking out all the white space. And to be honest with you, I got bored, and so I haven't finished arrays and multi-level objects. And the arbiter, I suppose, of what is valid JSON is this json.org BNF representation, back as north form, I think, of what is valid. So you can see it defines what an object looks like, what an array looks like, what a value looks like. A value can be strings, numbers, and there's the enclosing white space that may be there, and so on. Now, I'm sure that really clever people could take this formulation, or at least maybe this one here, that does the same thing in ASCII and generate a parser from it. But I'm not a really clever person, and this is an experiment in TDD. So let's go back to the code. And I'm going to commit those changes with add example and strict. Okay then. This is test-driven development. Can we run the tests? Well, it looks like it's trying, but we don't actually have any. So let's start with a test. I'm going to create one in here, and we'll say new Kotlin file class, and I'm going to call it JSON tests. Add it, and add in a test method, which we'll call, I don't know what, but test for now. And import that. Now if we run, we've got a single test. Good. Okay, so here are examples on the right-hand side. What's the simplest thing we can address first? And ironically, I think the answer is it's none of the examples, it's actually an empty string. So val empty string is that. So let's test the empty string. And this allows us to consider what the interface to our API should be. And I think maybe the answer is it's a single function, so that we would say parse an empty string. And we don't actually have that yet, so let's create it. And this is going to be a string that we think is JSON. That's good, and we don't want to put it in here. I'm going to move it to the top level of this file. It's going to go into production code eventually, but for now we'll just have it here so it's easy to work with. So if we run this, we expect it to fail because of that to do, which we'll throw. Let's just check. It does. There we go. Well, that's good. But what do we expect parsing an empty JSON string to do? Going back to the spec, white space is part of objects and so on, but I think if we start with an empty string, we've got nothing we can return. Now, we could return null if we have an empty string, but on the other hand, null is itself JSON, and my aim here is to use primitives to represent things we found in JSON. So I don't think we can use null, So I think if we pass an empty string or a string that's only white space, we probably have to throw an exception. Now, we could return a result type, but for now at least I think I'm going to go with the exceptions to keep everything as simple as it can be. So when we parse an empty string, expect that it will throw, and we have to decide what we expect it to throw, and I think the answer is illegal argument exception. Let's run that. And that doesn't work, and it doesn't work because we didn't throw an illegal argument exception, we threw not implemented error. But we can get it to pass simply by saying here, throw illegal argument exception with a message, and I think this message is going to be that not valid JSON, and then maybe a delimiter that we don't expect to find in JSON at all, in order that we can put JSON in there. Run that, and we've got our first parsing test. Good. How about other empty strings, those which are just white space? Well, we could create other tests, but I think I'm just going to duplicate this and have some others. So a single white space and a carriage return. It won't surprise us if these pass, but they're there to make sure we don't make any mistakes later on. So let's run that. Good. Okay then, let's think about null. We'll write a test. This is null. And in here, I think we'll say that we expect that if we parse a string with just the word null in it, what should that be equal to? Well, at the moment our parse is returning unit, which is why this can't compile. I suppose we might better say unit in there. Oh, we can. But we don't want unit, we want some representation of null. Now, JSON libraries often have things like JSON node, and there'll be a null JSON node and a string JSON node and so on. But I want this library to be as lightweight as possible. And so I think we should just say this is actually null. Run that. And it failed unsurprisingly. But now in here, I think we should say that this can return anything, including null. And in here, we're going to say if JSON is not blank, what's the simplest thing we could do? Well, we could return null. Does that pass our tests? Well, it does. Good. Again, I think we can add a few tests that we expect to pass but may help us later, which is adding white space around this, so that space null should also be null, and a space at the end should also be null. But it won't surprise us if this passes at the moment, and it does. Good. Okay, so far so simple. What about booleans? I think they're the next simplest thing. Add ourselves a test. Right, let's pull an expectation, and we are going to say that if I parse true, I want to get true, the Kotlin boolean. Does that pass? Yes, you're right, it doesn't. And that's because we are always returning null from here if the JSON isn't blank. Okay, let's tidy this up a bit. I think what we're going to say is that we'll replace this with a when, and then we'll reverse this to make it a bit easier. So we'll say that if it is blank, then we'll throw this illegal argument exception. Otherwise, well, our previous code would have just been returning null. But what's the simplest thing we could say now in order to get this test to pass? And I think the answer is probably JSON contains null. In that case, we want to return null, and otherwise we're going to return true. Does that work? It does, but it's a little bit naff. I think we should probably pull this return here out of the when. Okay. Now you may be a bit suspicious, and I think you'd be right to, because we're just saying this contains null, not that it's only got null in it. So I think if we were to parse a string like nullable, then that shouldn't return null. What should it return? Well, it's not a string, it's not an int, it's not a float. It's not a string because it doesn't have quotes around it, at least not that our parse is seeing. So I think that has to throw. So let's remember our expect throws, put that in there, and this will force us to be a bit more honest because it will fail the test. Well, I'm glad it does. How do we fix that? Well, the simplest thing I can think of is to trim the JSON before we ask whether it has null. Does that work? No, I don't mean contains null, I mean now equals null, because the trim will get rid of the white space. No, still not there. But the reason we're not there now is, I think, that we return the true from here. Well, that's not going all that well, but I think we might just take that line and say if it's true, then it's true. Otherwise, well, we'll take our illegal argument exception and throw that. Obviously there's duplication there, but let's just see whether it passes. It does, good. And I suspect that means that we could do without this line. Let's find out. And that is true. What's next then? Well, I guess false. So we should probably better say that parsing false is equal to false. Run that. It will fail as we expect. So now we can just add in false in here. That passes. No, it doesn't. Oh, because I'm an idiot. That should be false. Run it. And we're good. And now we can add those sets of spaces. So we can check that and that and that and that. Maybe even get a flash and put two spaces in the front. Lots of duplication in our test that we'll worry about later, but does that pass? Yes, it does. Oh, and I just can't live with that extra space there. Now it's interesting that we're testing for something here that we needed to put in the old implementation of parse, but I don't think we do anymore. I'm going to leave it for now as a reminder that maybe we want to mutate our inputs in some sort of way to check that they fail when we do. Okay then, on to numbers, I think. Let's use our simplest one, so that if we have parse 42, we expect that to be the number 42. Check it does fail. And it does, good. And now the simplest way to make that work is to trim our JSON and check it against 42. And that will pass good. And I think before we go on, we'll take the opportunity to not keep on trimming, but introduce a variable for this, which is trimmed. Okay. Let's write another test to force us to get rid of that duplication. We can use our float, which was 12.34. And we want that, I think. Now, do we want a double or what? I think for now, I'm going to say, let's use BigDecimal for all of our non-integers. So we'll say BigDecimal on 12.34. Check that doesn't pass. Indeed it doesn't. And now I think for expedience, I'm going to say that 42 will give us BigDecimal 42 for now. We're going to fix that later, but it'll make everything a bit easier here. So now we could try and pattern match things that look like numbers. Alternatively, we could just try to build a BigDecimal, and if it succeeds, return that. I'm going to do that by pretending that we have two BigDecimal or null. Oh, well, it turns out we do. So we can use that and say if that isn't null, then we return its value, which tediously at the moment we'll have to do by doing it again. Don't like that logic, but does it pass the test? Well, it does. And as this is our fallback, I think we can probably say not equals null, but Elvis, throw a legal argument. And then this is our else clause. Is that right? Yes, it is. Good. As we're using BigDecimal, I think we might reasonably expect these others to work. And let's take them and we will put them in here and then say expect that parse. Oh, don't know what happened there. Take it away. Is equal to BigDecimal 12.34 by 10 to the 5. And this one is equal to BigDecimal of minus 12.34. Are we good? Yes, we are. And I think for form's sake, I'm just going to try the spaces around the 42 version. There we go. I think it might be nice to return an int or a long if the string is representable by an int or a long, but let's leave that as a stretch target for later. Okay, on to strings. Let's expect that, parse, and then we need a quotation mark inside, so we'll use triple quotation marks like that, and then 1, 2 quotation marks around banana. And that has messed up. Thank you, IntelliJ. So there's our banana quoted inside, not enough quotation marks, so we need one more. What should that be? It should be a string of banana. Is it? No surprise there, but we can play our fake it till we make it game by saying trimmed equals banana, banana. But I forgot to put in the quotes, so let's escape them in this one. Good. Let's force ourselves to do better with hello world. So now we're going to parse hello world. And that should be hello world fails as we expect. What's the minimum test we could use? I think probably we could say trimmed starts with a quote. Then we should take all but the start and end quote out of it. So that will be trimmed subsequence from the first character, because 0 is the first quote, and the end index I'm always going to get wrong, but I think will be trimmed dot length. Am I right? No, I've got an extra thing, so we need trimmed dot length minus 1. Good. Does this work with some spaces around it? We'll do our normal trick of saying I'm going to put a single space in there, 2 in there, and then 1 after that. Yes, the trimming works well for us. But what about a string that doesn't have an end quote? Well, that isn't valid JSON, so let's take something like this and say that if we were to try and parse banana without an end quote, then we'd expect our illegal argument exception. So that is expect throws illegal argument exception when we parse banana without an end quote. Do we get that? No. And you see what we actually get back is banan rather than... I don't know why it's saying expected null there. I suspect that maybe it's the illegal argument exception that's null, don't know. But in any case, maybe we should say that it starts with that and trimmed ends with. And I think we could just use a character in both those places rather than a whole string. Messed that up a bit. And I'm an idiot, I didn't want \n, I wanted \quote. Is that right? Yes, it is. We're going to have some more strings to try, an empty string. I think we'll do that in place here. So if that's empty, we expect empty. Are we good? We are. Blank. We'll put a space in there, and that should be space. And we're good. And now finally we have string with a quote. I think that might cause us some problems. But let's just check. So we're going to take this string here, and we're going to say that if we try and parse that, we expect, I think I am actually missing a whole quote in there. 1, 2, 3, 4 at the end, yes. So 1, 2, 3, and 1 for our string, backslash quote in the middle, and then 1, 2, 3, and 1 for our string. So we should be this thing when we come out. I don't know why I put a backslash there. Get rid of that one. So I can also get rid of it there. And so this should be hello world quote. I don't think that will pass. And I'm right. What we actually got is that we didn't escape this backslash quote. So we left the backslash quote in there rather than having a quote in the middle of our string. Now we're obviously going to have to do a better job at some point, but I think for now we can probably just say with escapes expanded, make that come into existence. This wants to return a string, and I think this is return this, replace. We don't have replace all on char sequence, but I think we do on string. Replace after, no, replace, there we are, replace old value, new value. So for now at least, we'll just say if you find a string in the middle, that is the literal string, try and get this right. So we're going to replace backslash quote with a quote. Now subsequence, it turns out, returns a char sequence. So I suppose we'll go back here, we'll say this is a char sequence, then we'll say this toString, and worry about efficiency later. Does it at least work? Yes, it does. So now we can say this is an expression that looks like that. Good. Well, if it's not tempting fate, I'm going to say that so far this has been quite easy, although we haven't yet got onto objects and arrays, which are the things with structure. Before we do, I think we've got these things on the right-hand side here. Let's take our examples here and check that we can parse them all. So null is only one of those. Booleans, we've tried both. But numbers, I think we could probably say, let's go through numbers for each and check that we can parse it. That's good. And then we'll do the same thing for strings. Copy that, go for it with strings and say strings for each, parse it. And I think we might say that the thing we expect for each one of these things is expect that parse it is a BigDecimal. And in the case of our strings, expect that parse it is a string. Is that true? No, it isn't. Goodness me. Well, I'm glad we tried that before we got too far. What was wrong with numbers? So we actually got a Boolean out of one of our numbers. Oh, I put in a bool there. That was stupid. That should be easy to fix. What's here? Not valid JSON banana. Oh, well, thinking about it, these are strings, but they're not wrapped in the quote that's needed. So that was silly. We're going to have to say, well, triple quotes are not really working for me much here, I've got to say. So I'm just going to escape them here. That's backslash quote in Kotlin world. That's backslash quote. This is backslash quote dash quote. This is backslash quote space backslash quote. This is back quote. Well, you get the gist. This one we'd already done, but I think we will change for consistency. Is that okay? Yes, phew. A little blank line there. And I think before we go on and try anything else, I'm going to commit that. So this is parse single primitives. Have a little look at our code analysis. We're not using a null, bools, empty objects and so on. I think that's fine for now. Okay then, so much for primitives. The other thing we can have in JSON is arrays and objects. And I know I created the objects down here, but I'm thinking that arrays is probably simpler. So I'm going to remind myself what sort of things we expect to see. So an empty array, well, that's empty square brackets. Another empty array, well, we can put spaces inside and it will still be an empty array. An empty array with a line break, let's just remind ourselves that we can have line breaks inside the structure. So that would be something like that. And now an array with one item, well, that could be, let's say, a string. We're going to need to escape that in here, like that. This can be our banana. It will have a thing on the end. And I'm going to put a bit of space around it and have this one item and no space. So we'll take that space out of there. And now let's have an array with two items, and they don't have to be the same type, so we'll put in banana and I don't know what, let's say null. And this is going to be two items. And now for possibly the killer, what happens when we have a comma inside our string? So an array with two items, one with comma. So if this was our hello comma world, then that will force us to not just split on a comma inside here. Okay, I think we'll go with throttle up until we reach an insurmountable problem, and then we'll end this video and work out how to fix it next week. So, test arrays. Expect that parse a string with just square brackets in it is equal to. Now what Kotlin type are we going to use? Well, I think that's an empty list. It's an empty list of what? Well, anything really, because JSON arrays don't restrict what you can put in them. Does that pass? Unsurprisingly, it doesn't. So now let's go down, and we've already got this code here that works with strings, so maybe we can give that a go. Let's duplicate that, and then we'll say if it starts with an open bracket, and well, moral problem here because we don't have a test to show that we need this, but ends with a closed bracket, then at the moment at least we can just return empty list of anything including null. Is that true? Yes. Should also be true, I think, of an array with some white space inside it. Good. And with a new line inside it. Good. And also with space around it. Still good. But as with strings, if we don't have the closing element, so if we do that without a closing bracket, then that should throw. And that's taken care of by this, which we sort of cheated with. Okay then, what about our array with banana in it? Let's take this and we'll say if we have, well, we put it here, didn't we? So let's take that one. That should be not an empty list, but a list of, now the banana will pass to a ordinary string, so we expect to get banana. I don't suppose we can, and I'm right, but now we can look inside our brackets. So I think what we'll say is here, we'll do the same thing as we did with the string. We'll take the subsequence, and I think we're going to put a bit of structure in here. So we'll say, for now at least, this is our content. So that's the bit inside our brackets. And if the content is blank, then we want our empty list of any. Else, well, in this case here, our content is going to be this banana, but I think that means we can just use parse on the content. So we can return a list of parse on the content. And again, the content turns out to be a char sequence, so we're going to have to say toString on that. There's a chance that that's right. And it appears to be 100%, which is splendid. So let's just go and check, for example, that if we were to parse an array with, say, null in it, then that would be a list of null and true, and I'm going to just scatter spaces, is list of true. Well, that's good. I think I probably need not do that one, but it would be interesting to try this array with 2 items. So that's this one here. So we will duplicate that, and we'll say parse something with a banana and null, and that wants to be equal to a list of banana and null. Does it work? Well, unsurprisingly not, because here we're trying to parse all of this here into JSON, and that's not valid JSON. It's not valid JSON because it doesn't have the brackets around it. A string with commas but no square brackets is not valid JSON. But for this case at least, we can take our content toString, we can split it on the comma, and then we can take those bits and map them using parse. That compiles. Does it work? Why, yes, it does. But, and you may see where this is going, if we put a comma inside our string, we have problems. So if I take this and duplicate it and use that in there, what we expect to get back is our hello world as a string with the comma in it and null. And I think if we do that, it will fail. Why is that? Well, as you can see here, we ended up splitting the thing inside our square brackets on a comma, and the first one of those was hello, which isn't a valid string and therefore fails. And this is, I think, the comeuppance that we all expected for doing the simplest thing that could possibly work. We've just hacked it, and now we have quite a fundamental problem. So, comment that out, make sure everything else runs. It does. Commit it as parse arrays except those with strings with commas. Before we go, let's just remind ourselves of the process. We didn't just jump in blindly. We did make a list of the sorts of things we expected to have to parse. And then we started with the very simplest case and built up this parse function here with the simplest step every time we could use to make the test pass. So we started just throwing illegal argument exception. Then we differentiated between an empty string and null, and if we didn't get an empty string, we returned null. Then we added tests to show that we needed to trim. Then we added the booleans. Then we added the numbers. And every time we added some functionality, we did it because we had a failing test. And we did the simplest thing that we could possibly do in order to make that test pass, sometimes just returning literals, until we had 2 tests, for example, that forced us to actually parse. I think we've taken a bit of a liberty here using BigDecimal to see whether something is actually a number. The result, though, is that the code here is actually really quite understandable. I think we could pull, for example, is string out of this. Don't know where quoted came from, but let's just take that and make it the receiver, and then that is string. And similarly, I think we could use this and say that is array, make that a receiver, and probably just say this is a method which is parse array, and this is parse string. Good. Drop that down there. I think this makes a lot of sense, but we have a hole to dig ourselves out of with parse array. I don't honestly know how I'm going to do that at the moment, so I'm off for a bike ride. If you'd like to see whether I come up with any bright ideas, then please subscribe to the channel if you're not already. Be sure to like the video, and then rush to Amazon to buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.